welcome you to the session.
Good evening.
Good
Hi.
evening. I request you to kindly introduce yourself. Students, Sudhanshu sir is here for our session. So he will be going online now. Over to you, Sudhanshu sir.
Thank you, Marin. And hi. So as introduced, right, I'm Sudhanshu, and I'm with the IT industry for almost about 20 years now, and I have witnessed the complete evolution of IT support space, especially, right? And I have worked on various MNCs, right? So including Cisco as one of the key places where I have spent most of my career, and then I have taken up the trainings because that was one of my interest, and I have been training to people all over world, right, with different countries as well on this network security, specifically on information security part of it. And I have also had like a lot of certifications I did, CISSP as well as your forensic side, and I also have been certified by Defense Institute of Advanced Technology, and it has been pleasant to teach the students and know a lot of people and clearing their doubts, and it has been fun throughout my journey. So unless you need me to explain anything more, I would stop here. If you have any questions, I will be happy to answer. Okay, I will take that as no question. So Marin, right? Can I call you Marin?
Yes, yes.
So Marin, how are we placed now? Are we good to start, or are we expecting some more folks to join? Or if you
Sir,
want
we are
to,
good to start because it is 7, 8 already. So we can start on the session. Meanwhile, the people will be joining. That'll be fine, sir.
okay, let me share my desktop. Please do let me know once you are able to see my desktop.
Yeah, we are able to see your distance.
Go ahead, presentation more. Hmm. So welcome to the session of Wireshark, and I am hoping that this session is going to be more interactive with a lot of questions that you'll be coming up with. So Marine, if you have a minute, if you can just tell me who the audience is, like what are their background, in just to ensure that if people are not asking question, I will relate and make sure that it makes more sense when I'm explaining. Am I audible, folks?
Yes, sir, you're audible.
Okay, fine. Let's go ahead with. So all of you have installed this tool by any chance, or you want me to just use only my desktop on this demonstration when I'm doing?
We haven't installed, sir.
Okay. So about Wireshark, right? So this was earlier used to called Ethereal, right? So Wireshark, this is a free open source tool widely used today for network packet analyzing network packets. And whenever we want to troubleshoot, we this has been one of the key tool that people use today. Even during all your information security uh, trainings and all, this is widely used. I'm sure you must be knowing about there is an operating system called Kali Linux. So it comes integrated with that as well, right? With as part of the networking to the security tools. So this is a very handy tool, right? Which analyzes all the network packets. Like basically, you want to sniff what is going on, right? So this will try to capture real time and display the packet data as much detailed as it is possible. and it's well organized and easy to understand because it's not any complex things are there. So it's even including there are the passwords, right, whenever it is unencrypted. So those things are all text based also. It can be seen through this. So this actually helps us to know what is going on inside a network cable when you open a browser, right? What happens exactly? So right, so all those things it is actually going to tell us. So this is about the Wireshark, right? So there are a lot of features that we will just explain on through this session. So one of those is analyzing protocols, right? So we need to enable this feature. So by enabling capture in Wireshark, security analyst, as a security analyst, you can study the packets in great details. So a protocol can be studied internally, right? Here it is used to, in Wireshark, it is used to examine the security problems and troubleshoot them. So once you have captured some packets, you can also view them for offline, right? You can save those packets in your personal and in your local drive, and you can view that offline for your analysis. So that is about analyzing protocol, and we will come back to these, right? So some of the demo, there are key few of them. I'm just explaining what are the features, right? And then comes there is something called coloring schemes. So there will be coloring rules. Those can be applied to the packet, right, list for easy analysis. Wireshark allows you to use actually different colors to identify different types of traffic. So so that when a list of traffic is generated, one can easily identify the traffic of his own interest. What exactly is interested for you, right? You can see that through that, right? So uh, there are two types of coloring rules, by the way, right? So um, you have temporary and permanent. So these are the two types. So you can save as a preference as you like, whether you want that to be temporary or you want that to be permanent. So it's based on your choice. And then the next one is display filters, right? So what happens, the display filters will enable a analyzer or user, right, to limit the output. For example, if you only want to see the traffic from a particular port number, say for example port number 25, which is SMTP and ICMP, right? You can set the filter, and it will just display those, right? So it can be like, for example, TCP dot port, something like that. It will be filtered, and it will show uh, um, HTTP traffic also if you want to use, right? You can use TCP dot port, that 25, or ICMP is one of the other things that we will use it. I'm just calling it out. So for HTTP traffic, right, is I'm just calling out. So you can use TCP dot port equal to 80. That is a rule. So some uh, display filters like that we can use, right? And then comes your follow TCP stream. So what is this feature? For TCP based protocols, you can see the data from a TCP stream in the way that the application layer will actually see it. So Wireshark will set an appropriate display filter and display also a dialog box with all the data from the TCP stream. So the stream content is displayed and in the same sequence as actually it appeared on the network. So that is your follow TCP stream. So let's take an example. So we can identify complete TCP communication, right? By there is something called handshake, TCP handshake. There are three-way handshake, It's a very common one, right? So the filter for TCP three-way handshake, it will be it's like something like TCP.flag.sin equal to one, and there are some of the flags in TCP. I'm not sure if you have gone through the OSI modules and the TCP headers, flags, and all those things in the past. Otherwise, I will just show you there in the Wireshark itself. So this filter will identify based on what actually you are going to use, right? So the TCP conversation and then capture will start. The packet capture will start. And then about multi-platform, you must be knowing, right? So multi-platform in the sense of it can run on Windows, it can run on Linux, and you can also run on Mac, that OS X, Solaris, and then FreeBSD, Unix, and you have your NetBSD and many other operating systems. So it can use any of these, right, as a platform. So it's widely used. And then the last one is capture filters. So capture filters are used to filter and display specific packets. So to capture packets from one particular IP address, for example, right? So you can have that as a filter, saying that host space and that IP address you can give. And similarly, you to capture packets from a single range of IP address. So if it is single IP address, you can give one IP address. If you want to use from a range of IP address or a network particularly, right? So there will be a command syntax like net space, then that IP address range. You can use the CIDR IP addressing schemes as well as. And then if you want to capture traffic from a single port, also you can give port space, that port number. For example, port 53 is for DNS and port 80 is for HTTP. So something like that, port space 80, if you give, it will capture traffic from a HTTP port. Similarly, you can capture traffic from all the ports except DNS. So if you want to filter like that, so you can put port space not space that port number. So those are the things that you can do. You can also capture only IP traffic, right? So shortest timer. So you can give only IP is the syntax, and you can capture only unicast traffic. So there are a lot of traffic which goes to many things, right? So broadcast it happens. So you can capture, limit that to unicast itself, right? So there, that time you can put the syntax something like not broadcast and not multicast, so that you get only unicast. So those are the things that as part of features that we have in Wireshark, right? I thought if you have installed, if any of you have installed Wireshark, then you can actually do a demo along with me, so that it will be practically possible for you also to do what I am doing here in my screen. And then next one is the demo that I was talking about. There are two things we will do as part of today's session. One is we will capture the TCP three-way handshake, and we will also view ICMP traffic, right? So let me share the tool. So let me just open the tool, Wireshark. So let me know if you are able to see my screen with the Wireshark Network Analyzer as the tool. Am I audible, folks?
Yes, sir.
Okay. So this is the Wireshark Network Analyzer tool. If you want me to close and open, it's not. I have opened this tool. So this is how it looks like. When you open this tool, this is the window you get. I hope my screen is visible correctly, right? So here you have the tool name, the Wireshark Network Analyzer, and you have various menus like File, Edit, View, Go, Capture, Analyze, Statistics, Telephony, Wireless, Tools, and Help. These are the menus, and here are the shortcuts for that. For example, if you start capturing packets, you can just click on this, it will start capturing. So our first demo is, let's capture a three-way handshake, TCP three-way handshake, right, in Wireshark. So before capturing the three-way handshake, there has to be a TCP communication. And that, TCP communication, when I say, right, um, anything, for example, you create a you open a browser and type www.google.com also, right? I think I'm not sharing my entire screen, so let me share my entire screen so that it will be more useful. But anyway, so if I capture, for example, right, it's like this. When I stop, no package capture. Now I will have to select a interface, wired or virtual, and see here I will have to open something on this, right? Let me. So we will have to wired. Nothing is wired, so I do not have a LAN cable. But let me see if there is anything that we can do. So I'm just trying to share my entire screen. Actually, it looks like there is some issue on this, and I have to reinstall that. But what I'll do is, for now, I will just go ahead and open the pickup file which had captured, right? So based on that, we will just go ahead and analyze, right? So I will show you all the things here, right? Once you capture a packet, it actually, you when you are saving, right, file and save as option, so it will save as a .pcap file, something like this, CPF. So these are the Wireshark dumps, TCP dump, for example, right? So once you capture here, it becomes like that. So unfortunately, this is asking me to upgrade the software, but we will manage with this. Okay, so if you see here, all the packets, if you see here, right, so every details for every line here, you can double click and you can see these details here, right? So in the section, if you see, there will be, um, let me just go one by one so that this is see, in whatever you write, so you have what was exactly the time, where was the source, what was the destination, right, what protocol it was used. So for example, we are trying to see something for TCP, right? So TCP dump, right? So if you see here, this is the TCP one, and there are there will be a lot of flags. For example, SYN, ACK, right? So SYN means, you know that synchronization establishment. ACK is for acknowledgement. You know how the TCP, how that the three-way handshake works, right? Let me just take a whiteboard, right? I will just draw here how the TCP handshake works. So based on that, for example, you have a host here, right? You have a computer here, and you have another one here, right? And now the first one, right? The first, when you establish a connection, right? When you establish a connection, first there will be a SYN request, okay? And then, sorry, okay, and then there will be ACK, acknowledgement, and after that the connection start. Actually, this is three-way, right? One is the SYN, okay, and then there will be SYN acknowledgement. After that, it will start the connection establishment, right? It will start after that. So in this three-way, right, what you see here are those flags. When it started, see, it started. Let's say about this, right? Okay. So what was the time it started, and what is the length, right? What is the protocol? What is the coloring or TCP, SYN and FIN, right? FIN is for finished, right? So coloring rule was also there, as I was telling about coloring rule, right? And then the flags. So what is the TCP flag? It used here TCP dot flags dot fin equal to 1. So this is the rule actually, okay? And you can see, so this is basically on the Wireshark, right? So if we give, if it is SYN, it will be, instead of this FIN, it will be SYN equal to 1. If you give this filter, it will show only these flags, SYN, right? So if you give ACK equal to 1, flags dot ACK equal to 1, you will see only this, okay? So this is how actually the the Wireshark handshake happens. I mean, the TCP three-way handshake happens in Wireshark. So usually info section gives all the details. Your capture length, frame is marked as for, so protocol, what protocol you have used. So Ethernet 2, for example, your destination, your source, MAC address. This is the, if you have gone through the OSI layer, right? So if the MAC ID is there, right? So your media access control works at layer 2, right? So the Ethernet 2, so your destination, your source, MAC ID, right? So it is given, and then what type of IP version is used? It's your IPv. What type of that IP address is being used, right? Similarly, um, here also the IP address, source and destination. If you see IP, IPv4 source, this is the source, this is the destination address, right? You can expand that as well to go a little bit more and more deeper. What was the header length? How many bytes, right? And so why do we need to know about the header length and bytes and all? So if somebody is going to hack, right, there are men in the middle who can also change the header length. So header is, what is header? Header actually holds all your information of source and destination, where it is coming from, where it is supposed to go. So that it's header is something like, you put a letter and put in, post it, right? So before you courier it, or before you send through post, that you need an envelope where you actually write the source and destination address, mainly destination address, right? So that is your header actually. So if imagine if a hacker get access to your the header and he's able to change. So instead of that going to the right destination, he can change it to his command and control server. So you need to know what is the header length. If there is anything abnormal in that, right, that is how you identify that there is something wrong. This packet, there is something wrong in this. So somebody is trying to steal your data, or somebody is trying to hack into your system. And then so the byte length will be the one, right? So total length. And sometimes they will even uh, try to modify the payload as well. Payload is nothing but the content that we are talking about. So there will be a lot of things that you set as a baseline, right? So this is what it looks normal. But when you sniff it through Wireshark, if you find any of those abnormal, then that's an alarming state. So that is one other thing, right? So you see here, flags don't fragment. So it's like don't fragment. What is fragment? Fragment is something like, say you have 1 GB of data to be sent, and imagine your fragment size is allowed is only say 1 MB, right? So it will be that many fragments it will be done, right? And it will be sent uh, one by one after one in a sequential manner, and receiving, and also once it is received, it will be reassembled. So, and then time to live, right? TTL, it's like how much time it takes this to from source to destination. If it goes beyond 120, right, it'll time out. And protocol, TCP, yeah. And then what else? Yeah, source address, the IP address, and destination address. So this is about the IPv4. Now TCP, transmission control protocol, this particularly this, right? So this has again at the transport layer, right? TCP works at transport layer, which is also called as layer 4. So there you will have your source port and destination port mentioned. Okay. And what is the segment length, and then sequence number, and then you have, so if there is, if it is multiple segments, right, so that the sequence number will be right, based on what data has to be sent first and all those things, it will be mentioned. And then acknowledgement number, and then your flags, as I was talking about, ACK means acknowledgement flag, right? And what is the window, and then calculated window size, or window size scaling factor. And so if there is any points, urgent pointers are there, right, so to bypass the sequence, right? So all these things are part of your TCP, your TCP dump. Actually, in this we could have captured a live real-time one, but unfortunately that was not done. But this is as good as that itself, because once you capture, this is the data which comes actually. So this is the data it comes. We just took TCP. Similarly, you can take DNS, right? DNS also will give all those those category of information, right? Your layer 2, layer 3, what happens, right? And there is something called UDP, right? So UDP is, I hope you understand the difference between TCP and UDP. So TCP, when something you are sending to a destination, and it reaches for sure without any data loss in the middle. So that is your TCP, right? For example, your WhatsApp message, your emails, all this, whatever you send, it reaches 100% accurate, right? It's called connection oriented, and it guarantees the delivery. But UDP is another protocol which is also as it works at layer 4, which is the transport layer, right? So this is connectionless. This does not guarantee the packet delivery. So some of the examples, it can be, right, when you are watching a movie, some packet drop happens somewhere, or some YouTube, you are watching a video, something like that. So this is wherever there is a wherever there is a fast connection required, but there is the the speed is required, but you don't want to give guarantee of the data delivery. So there it is used UDP. So if you see here, source port, destination port, everything here also in UDP also it is mentioned, right? So this is, and then DNS response, so many details. So every packet, if you see, there will be details of this marked here. Let's see if there is any other. Okay, so okay, now in addition to this, what else we have is, there's so many of them. So let me search if there is anything on ICMP. So DHCP is, yeah, so DHCP also is there. So for every category, you will find the same sequential data, detailed data at that level, right? We see here, right? So if there is any password or something happens, right? So you will find it here. Okay. So what was what did they access, which website and all, for example, right? Some see here, right? So this kind of information you will get it. And what else can we see is, so your filters are applied here. Apply a display filter. I was talking about display filter, right? So filters, you can, for example, if we want to see DNS, right? You can enter or just put here. It will show you only DNS stuffs here, right? So this is the display filter that I was talking about, right? So if I have to capture ICMP, then I will have to just type ICMP, right? So and enter. There is nothing, no ICMP. I think packets are there. So with TCP, it will be all the TCP related. So this is the viewing the traffic using Wireshark, right? There are several things like environment variables, right? So when we need to use Wireshark remotely, so this is your local, right? When you want to use it remotely via SSH or tunneling, right? Secure shell or tunneling, the remote content will have to actually be transported from their network to our end of network analyzing, because we need to make sure that it reaches us. So Wireshark environment variables will give us information about the remote connections, right? So when I say remote connections, it is the remote IP address, the port number, etc. So there are some of the environment variables. It will be like SSH underscore connection or SSH underscore client, remote host, something like that. So how do we can somebody say that how do we identify the flags in Wireshark, right? So once you get a chance, you install this. This is free open source, and anywhere you see how, when I say identify TCP flags in Wireshark. How will you actually do that? Anybody tell me how do you identify the TCP flags? TCP flags, right? So I told you that SYN, egg, and all those things, right? See here. So these are the TCP flags. So under info, you can see that and identify it, right? So what is the filter we should provide? Ideally, when you're capturing, it should be something like your TCP dot flags, right? Here it came, right? TCP dot flag dot ACK or fin. So these are all your TCP flags, right? Reset, RES for reset, SYN for SYN. So something like this you can put always. Select this, right? And you don't need this, right? So when you select like this, it will give all the TCP flags with acknowledgement as the flag call out. So any question on this? For every line here, if you see, you will have the frame information in detail, right? How many writes, whether how many bytes, and on wire it is how many bytes captured versus how many bytes when it is on wire, and encapsulation type, whether it's Ethernet, and then arrival time, your time shift for the packet, right? And the frame number, frame length, everything it is captured. So anything abnormal, anything goes beyond this, right? So you will have it marked, right? So that you will see there is an alarming situation, whether some alert can be created or event can be created based on the findings that you see here. So that is pretty much about this Wireshark demo, right? So usually the flags and the details, how depth you are going and analyzing, that is what actually makes a lot of sense, right? So net login, let me see what else can be found out. HTTP. So we will see if there is any kind of a HTTP password issue where so these are the frames. We can go one by one. See the details, right? If you go to the frame level, so you see here host, this is what it is, and you have a login here, right? So by name user is agent Mozilla, right? And the Windows NT was the OS, right? You see here Chrome, and I'm just trying to see if there was any password that was captured. Okay, not on this. So usually you will see if there is any uh, password or any text, right? So it will come on this frame level. So details here you can see. So people are capturing your password if you use HTTP where it is not secured, right? Uh, so these are the places where they come and see what you type and what exactly you use, everything. Okay, any questions that I can answer for you guys? Anybody? I hope I am audible, right? I'm not hearing from anyone. Any questions? Whether you have understood anything or you didn't understand at all. So if there is anything like that, please do let me know so that I can answer. All right, let me stop sharing if there is no other question. Okay, folks, if there is no other question, then I think we can wind up. Thank you very much.